actionable. Okay.
I mean, she's the one who's configured this meeting, so.
She's in Jeff's working group,
Routing working group?
the routing working group. There's
Was
a
this
routing.
morning? I thought it was yesterday.
It was both. That's why she objected to early, and
I should really go to routing working group, but my brain was full this morning. I decided to take a brain break.
that's fine. Okay. I haven't seen. We're going to just start. This is going to be much more informal and discussion oriented than even Monday. We're going to look at version 7 of the text to try to close it off, because after that, oh, just a minute. I should do the note well, shouldn't I? Here comes the note well, guys. How many people haven't ever seen a note well? Well, maybe he needs to note well. Here's the note well. Do read it. Any submission to the IETF. As a contributor, you should read this and figure out your rights, the IPR, and that's the note well. Okay. So now we have the blue sheets. The rest, this is going to be a very open, laid-back discussion. So either join the front or speak loudly. Okay, so we've been discussing on the mail list requirement 7. I'm going to put up Joel's last comment. Did you that I see on the list? See if we like it.
Joe Clark, Cisco. Yes, I replied to it. I had one clarifying question. Other than that, I did like Joel's
You like
text.
Joel's? Okay.
He said I2RS agent priority, and I thought maybe I2RS client priority.
I think that's
but
what he,
other than that,
I
yeah.
think that's probably what he meant.
I'm sure that's what he's meant in the,
That's fine.
okay, so we'll take Joel's text on the list. So that'll be our new text, and we'll consider the ephemeral stuff closed. And we'll take it to
Last call.
last call.
Well, you're going to publish a new version with this, and then we'll take it to last call.
Yeah, but it can go a short 1 week last call.
Yeah, I'm just saying, but yeah, once you publish it with that text and the other changes you made, then yeah, we'll go last call on it.
Wait, is that agent? It has to be agent, Joe, not the, if you consider the ephemeral as one whole, it has to be agent. I don't think client. It's agent's priority. Okay.
I think Joe Clark. I think what he
Oh, do we use Scribe?
Oh, would anyone like to scribe today? Type in Etherpad any few words. Volunteer.
The volunteers are just coming out of the woodwork.
I could see it. Okay. Well, speak it loudly at the recording, because otherwise you won't get noted in the scribe. We can do the scribing later. Go ahead.
Yeah, Joel did agree with me. I mean, we're saying that he's saying, and I tend to agree, that it's not the entire ephemeral config. We're saying that the client that comes in has a priority of this, writes a ephemeral config with priority of that, and then we're saying we want to be able to override that with local configuration.
Yes.
Yes.
And then does this say that?
Right. I agree, but I think it's the client is the thing that has the priority. Sorry.
But when you're comparing it, you're actually comparing it in the agent.
Okay, the comparison would happen, yeah, on the device side, but
That's why I thought it was agents, Because you're comparing, you've got one plane for ephemeral, you got one
Yep.
plane for local config, and you're comparing it in the agent.
You're comparing it in the agent, but the priority is comparable to what the client has, because I don't think in the architecture anywhere it says that the agent has a priority.
Okay. Okay, we'll run that one more time on the list and make sure it's okay.
Thank you.
Okay, that sounds great. Okay, so the rest of it is fairly simple today. After that discussion, we're going to go through a couple discussions on the model, tell you what's good, bad, and changed, and see if anybody can give us some discussion feedback. Harry, I was hoping maybe on the rib you'd do it. Alexander, and then G on the topology things, because we're trying to close off the discussions on the model and decide if we're ready to send it to working group last call. Okay, I combined all of your model stuff into one. Hopefully I didn't. G sent me a note that said, hi, you have the wrong file, so I'm going to give the combined file, but if you think your slides are wrong, just let me know. So I'll start out with the rib, and Edwin can comment because he was doing some of the hacking with me. First, I'm going to harken back to John Scudder's review, which had a couple really good comments. He said, why didn't we put in a rib ID? You know, we put it in a name, but not a rib ID. And every place else we had a name and a rib. And in reality, looking at the code, that might be a better. So that's a suggestion to the working group. Any questions about the suggestion? I think we'll give it a shot with code and see what happens. Why are the restrictions on the next, where are the restrictions on the next hop chain? Certain things in the next hop chain might not make sense. Chaining interface to interface IP might not make sense. So that's another piece where as we walk through the code, we seem to have problems. It's unclear in the text, and I think that may be editorial, while the next hop is problems. It also is unclear how end next hops are chosen. Okay, so I think these are pieces that we need to discuss on the list. Did anybody see any of these in the list and the ribbon sort of want to discuss? Otherwise, I'll take this to the list. But I thought many of these were really good. Why is the reason for change notification and then for next hop change notification? I found that in coding. Why am I not giving some sort of error? Leaf family. So I'm going to send in, based on John's stuff and my work, some suggestions or some improvements to the route mib. So I think we need to take another crank on that. Edwin, I had a note that says no next hop change without informing a parent route. Was that what we talked about, or is that me misremembering? Lincoln.
The Edwin Cordero. So this was a comment because two documents, they were giving different structures. For one example, all the next hops were attached directly to a route match. And for the implementation, it was a little bit strange. So what we were proposing is that they were in the same hierarchy, and you would point to the next hop, because then the next hops could be shared. And the new version of the document seems to be better representing that.
Right, so that when you add and delete the next hop and it's shared, it might be shared between a whole bunch of routes. You need to inform other people, right? It's attached. It's one. The other question I had, and that's one I'll float on the list, is our next hop basic is fairly extensive. It's got every type of encapsulation. Should it just be IPv4 and IPv6? It should be all the encapsulations. Why is that? Just,
You may have, that's one of the things I've been looking at more seriously. You may have,
want to try the, just so we can capture it on Mechanical, and then I can catch the notes next week.
Pedro Aranda, Telefónica. I think I would not restrict that to just IPv4 or IPv6 because you may have address families there and VRFs and stuff that you may want to have the information in the next hop for.
Oh, I agree that you should have it. The question is whether the structure in the switch, that's the minimal, when you go through and you parse it, you have the keyword of next hop basic.
Yes.
Should that next hop basic just be IPv4 and IPv6, and then the next thing down say next hop extended, which would be all the other tunnels, or should the basic really have all the tunnel pieces?
I think you should unify that to just one because at the end, for me, it's the same whether it's a basic IPv4 or IPv6 or something that has more. I think it's a next hop. So
Okay.
I don't see this distinction between basic and extended to be important.
Okay, I was looking at efficiency of code, but we'll put out the code and leave that one. But the informing of the shared route and some of these other comments, I think we've got to take care of. I mean, these are just, we've implemented pieces, or John's looked at it, who's actually done a lot of coding. We should at least have answers. We can say the rib's fine, but the code should inform this stuff. Okay.
So Robert Raszuk, so the most powerful feature of next hop is actually recursion. So it doesn't really make too much sense to load it with all the attributes of the tunnel, let's say, because it will recurse anyway through the one with the tunnel. So if I have 1,000 routes in the overlay, I put it with the I2RS, and one route with the tunnel and next hop, that's what the information belongs, not to the overlay layer. And that's the big gain to actually keep it different.
Pedro, and I think it is merit, and I would really need to think about that. But I have seen that even when you recurse, at the very end, you end up by ending in a point which might be a VRF linked or something that is not basic IPv4. No, I have to think about that, but I think it's not.
Okay, so the idea is we will code pieces and then send out both code and comments on changes. In other words, we'll make, some of these are unclear, like are there restrictions in the next hop chain? That should at least be covered someplace in the document. And how are the next hops chosen? The rest we'll try to give code examples and try to actually be practical, because it may not, we've done the informational draft for a long time and logically that holds together, but these pieces are code and how the Yang model holds together. So we're not going to go switch over from sort of a theoretical and we'll start a mail list and I'll sort of put code snatches out and when we'll put code snatches out and we'll see what we can do. But this is just to tell you we're sort of transitioning into a Yang that's saying, what does the code do? Okay, I think it's your turn, Alexander, on the topology. The mic's either here or there, your choice. This is the front mic. We have to sort of raise it up, I think.
Yeah. Well, this one is high enough, so why
Okay.
don't I do it? Or
You can take it out of the, you can also take it out of the mic handle. Yeah,
Okay.
it walks.
doesn't work.
Okay, so I spaced it out so I could read because you're, instead of tiny print, you have several pages because I made the print big enough to see in the back. So
All right. Okay. So this basically concerns the Yang network topology. So the base topology draft And essentially the main issue, so there are basically two new revisions that have been put in since the last IETF. The main topic, main discussion has been actually for a long time basically this issue to deal with the configurable versus read-only topology. Again, just as a reminder, basically in the model we define the topologies can be layered, so you can have a topology at one layer and basically have a overlaid topology on top of that. And it basically means that the topologies, the nodes, the links, the termination points, and so forth can reference supporting nodes, links, termination points, and so forth at lower levels of the model. And topologies themselves can be provisioned by a controller, or they can also be discovered, basically come into being basically from the network operations. And this also implies that topologies could be configured or could be configured on top of other topologies that had been discovered. And so basically regarding that, there was this issue, okay, should this be read-only configurable and so forth, and basically how do we resolve that sort of issue? Can you go to the next slide, please?
Just a minute. Okay.
So there were various solutions that were discussed. Actually, we went now finally full circle, if you will, and came basically back to the pretty much to the original model that we had quite a while ago. And basically, the solution is that but there's also now in a document in the draft that we have the same model. Whether the topology is discovered or whether it's configured by a client application. So they all basically instantiate the same part of the same Yang module. We do have a leaf that is a read-only operational object that basically indicates the source of the network topology. Basically, it indicates whether or not the topology was discovered and essentially populated by the server, or by implication, basically by omission, whether it was configured by a client.
May I ask, is this the solution that Yifeng had initially suggested?
That is the original solution that is that also went into the original Open Daylight implementation. So we had other solutions. I'm not sure actually if it's on the other update, but we had we had discussed basically a number of alternatives. One thing was to split the model into a state portion, into a configuration portion that had various issues having to deal with how you augment, how you extend the model. Then the last item that we were, here are the some of the solutions that some of the alternatives that were considered. Another alternative that we had considered was to use a Yang extension to tag the server provided info. Something that Yifeng had also suggested, but it turned out basically that also for the Yang Doctor review that is not necessary, and also actually it's preferred because that this is not the implemented solution. Right? The one that is implemented is the one that we have gone full circle on now. This is just for a reminder. That is basically the overview of the model. Actually, there are two modules basically within this: the base network inventory, and then basically the network topology, which includes the link and termination point information. This hasn't changed, so I don't think we need to go through the details here. Basically, in terms of the updates in the draft itself, there are just very small editorial updates to the text and the descriptions. To close the discussion of the issues and so forth. One of the questions that were raised recently on the list were also basically why do we model network types as containers, not simply as identity refs. I think that issue is closed. But basically, fundamentally, it's a design choice, but basically it facilitates allowing networks to have multiple types simultaneously, and also automatically this. Essentially reflecting the hierarchy and the inheritance hierarchy, basically of the topology. That basically topology is also part of its supertypes, if you will, in the model. And then finally, there is another topology model, the layer 3 topology. That one just had a refresh release. It hasn't really changed. It did undergo also Yang Doctor review. was deemed in reasonable shape. There are a few updates needed. Actually, we are aware of that. Particularly many of the, some of the ISIS and so forth objects actually require updates in terms of the description and so forth. And so basically some of the draft updates that are needed are editorial clarifications. And yeah, we have some of the authors here, so hopefully we'll find some time to meet here still during this week. And the other suggestion that was made to also coordinate with the young authors of the OSPF and ISIS working groups, because there are submodels defined in the 83 topology that talk about OSPF and ISIS specifically. So that is, we need to make sure that we have a consolidated picture. Questions?
Questions? Okay. I want, it is the intent to the next step to be to go to working group last call. And based on discussions we had with Benoit yesterday, to go ahead and do this in advance of even the NetConf NetMod working group settling on their op state versus non-op state. So we can, that is the chair's intent, is to do a working group last call once these editorial pieces come in. Are there questions? Okay. G, do you want to give your short discussion? I think I'll bring up your slides as you sent me.
So here are some brief updates about the layer 2 topology model. We received some comments from the routing directory review, so make some update accordingly. Basically, this layer 2 topology model is based on the generic network and the network topology model. Some augmentation for the layer 2 specific attributes. So this time in this latest update, we add the system MAC address in the layer 2 node attributes, and also the VNID is added for nodes which support VXLAN. For the layer 2 termination point attributes, we add the layer 2 address for the legacy termination point types. This is the most of the update in this version of the model. And in the description, we clarify that this layer 2 topology model can be used for both the physical layer 2 network topologies and also the logical and virtual layer 2 topologies. So I think this is all we have in this update. And we would like to have more reviews from the working group and to see if there's any missing parts in this model or in the descriptions.
Thank you. I'd like to also ask, do we know of any implementations of the L2 portion of the model? Okay, I think we'll send through the ones with implementation, and we can always augment this as we get an implementation or an initial idea. Thank you, G, for your time. Okay, so on our agenda for today, we've made good progress against our time frame, which was very short. We've done our model discussion, and we're about 5 minutes early. One of the things we discussed in the past on the mail list extensively during after the Yokohama was some of the conflict resolution. And Pedro has been working on some actual implementation and wants to share with us some insights. So I'm going to bring up his presentation next.
Okay, good morning. Thank you, Sue, very much for the introduction and for the possibility of sharing this insights with the group. This, as you see, this comes from a no, that it's good, lad.
Okay.
I like that. So it's fine. It would be fine with me.
Okay.
So this comes all from a project which is called NetIDE, part of the FP7 framework in the European Union. And although not specific I2RS, there are some, we've been doing extensive work on conflict resolution, and I think we have some general results which might be interesting for you as a working group. So please next one. Okay. As said, this is results from the NetID project. It was very open flow centric at the beginning, but we are extending it, but they have been extended to cover other protocols. So current status, open flow, we are version oblivious in all the things we're doing, and we are extending that to anything that is supported on netconf and as a protocol. Next one, short recap of the architecture, and I think there's some, it was partially even inspired with by the architecture you have been working here on in I2RS. So we have an open flow controller in the bottom, which is what we call the server controller framework. That has a short shim layer. Then we have a core layer where we do all the magic regarding conflict resolution and application composition. And then at the top, we have three wonderful, well, we have another layer which has the controllers, the client controllers, sorry. And those client controllers are those that are actually executing the applications for the different applications. Actually, we go into more, a further step and say that the applications that are being executed in the top are actually just modules of something bigger. And that's what we call our NetID application. So it's multi-controller support, which was something very important for us. Lots of people coming from the university, wonderful experience in smaller controllers, like, for example, Rio, which is Python, or Floodlight, which is Java, but small scale. But if you want to go to a bigger production environment, you need something at the bottom, something facing the network that is more reliable. And that basically the work my team did was more on Open Daylight, and within the project we have partners who are very proficient in ONOS, and they've also been working on the network controller facing the network elements, being ONOS. And all the things you see here, very much what the ONF is saying about SDN architectures. Next slide, please. So our model is, you have a module, okay, that might be receiving an input, an event, or no input, or multiple inputs. This is why I'm putting here that famous star in the events. And that module, which is basically a small SDN application, may generate 0 or more commands. That's the general model of the OpenFlow application. If you say you can receive events or not, and you can produce commands or not, I don't know if that's a model or a non-model. That's my first question. So one of the things we did was simplifying that. Please, next slide. So we wanted to look at conflict resolution, right? So we had to do some assumptions. First of all is that if you have the network state as such, any command isolated with no context will not produce any kind of conflict against the network state, because you really cannot tell whether there is a conflict or not. There are things that may sound like conflicts, like, for example, you have a network interface and you want to shut it down, despite this being currently active, but there are applications there that do that for example, energy efficiency. There's no conflict in that for us. Another thing is you have a prefix and you may want to change the next hop for whatever reason. For example, you have a link that is overflowing, that is really congesting, and you want to put some of the traffic of that link onto another link to avoid congestion. The other thing we said is, okay, if you have a result that is not what you really intended by doing these actions, if that was an isolated command, you have to look into the application you wrote. You cannot rely on someone on telling you that this is an actual conflict. You have to look up. And the other thing is that in this case, for us at least, the network element should not try to resolve any kind of conflicts there.
Sorry, quick question, Alex. What do you mean with conflict? Confused actually why is even result is unwanted? I mean, usually you have conflict between multiple things, or conflict
Yes.
conflict between what? What's
No, I mean, yeah, this is exactly first slide. There is a conflict. What I want to say here is that if you have a given network state, an isolated command will never conflict with this network state. This is one of the things we had a long discussion on. So you really need to have that would be the next slide, because you really need to have more than one.
This one?
Yeah, you really need to have more than one command that is generated by the same event to start speaking about conflict. If you have an event that generates a command with one module, and that same event generates another command on another module, then you can start talking about conflict resolution. That's the whole message. So one of the first things we did is, for me, a command or a series of commands isolated from the rest of the context does not make sense. So what we did was actually binding the resulting commands to the event that generated them in the module. And that's what we call a transaction. And for that, we actually went into some of the controllers and started implementing hooks so that you can actually delimit when what a transaction is. Next slide, please. So when you have transactions, and when you start doing working with transactions, then you can start to talk about conflicts between commands. Why? Because when you have two or more transactions that are triggered by the same network event and sent to the network, then you can actually define what a conflict is. For example, if one application tells me to activate an interface and another one tells me to turn it down or to shut it off, then there's a conflict there, and there's something that you can actually start doing actions.
Is another example, one client says, set this route to this next hop, and the second client says the same route to a different next hop.
Exactly, that would be another one, or set, I always say shut down or activate an interface, but the next hop is a wonderful
secondary example.
Yeah, it's even a better example than the turning on and off the interfaces.
Joe Clark, but meaning two requests with the same priority.
Yeah, two requests with the same priority generated by the same event. So that's the whole thing.
That's a very good refinement of my
Yeah,
comment.
no, of course. So next slide, please. We actually started looking for exactly for these things in another context, and that was composing applications. You have different SDN applications there, and you want to do things together. One of the classical examples, if you have a firewall that is facing the internet, and then you have a layer 2 switch that is doing your functionality in a DMZ, in a data center, you may want to implement those things as SDN, and then suddenly you find a couple of very interesting effects. Next slide, please. Actually, you've seen it, you've seen that the logical way of thinking is you have the firewall before, and then you have the layer 2 switch. But actually, when you go down into SDN, one of the things we found out is that you can have the two functions in parallel, and then have a block to do the composing or conflict resolution. And you do that in parallel, and you can do that in parallel because actually the same packet is going to be triggering the firewall application and the layer 2 switch application. Next slide, please. So one of the things, we are currently doing all these things in OpenFlow. There's code available in our GitHub. We have a GitHub with all the code there. If you want to experiment with that, we are working currently with the integration of NetCompass, the carrying protocol, and then looking what is inside there. And the other thing where I really need to have some sort of help here is what happens when you have applications that are proactive, i.e. they don't they generate commands without any event in the input. That's something that we are looking at. One of the things that one of the situations that normally happens, or that is very normal, is when you start up an application and that sets up the network state at the beginning. That kind of things is something we are currently looking at, and if the working group has any ideas, place them on the mailing list on how you would like to see that interpreted, because that may be also interesting for us. So next slide. I'm sorry, I forgot one slide. I forgot to send you one slide with the pointers.
Oh, okay, just send that.
I'll send that slide to the mailing list.
Yep.
Again, the code is available. You can mix and match all kinds of applications there, and although it's OpenFlow specific, I think the concepts might be interesting for the group to discuss and to further elaborate. So the GitHub is netid fp7.net/netid, and there you'll find everything, all the code we have.
If you would send that to the list, that will
Yeah,
help people get.
Yeah,
Get
I'll
it.
send that extra slide. I don't know why I didn't, why it was not exported, but anyhow, I'll send that extra slide to the list.
Thank you. That's
Okay.
very.
Thanks a lot for the opportunity of presenting this.
Oh, you're welcome. One thing that's really been interesting, another part of his group was looking at firewalls and looking at resolution of firewall conflict rules, which applies to our filter-based RIB, because in the end, how do you define if two filters are conflict? Right now, we just have two entries based on a prefix and a priority. And that's about what the basic RIB is, but their group went on and tried to talk about at a higher level for the application. What does it mean to have rules conflict? What are the ways that people resolve it? For example, if you have a global security policy and then a local security policy, there's a resolution for security devices. Now that's above I2RS work for just setting the filter-based policy, but it's interesting to know the applications because it may help us understand what we're doing.
Yeah, and as you say, right now it comes to my mind that if you really abstract a bit, all these rules, all these OpenFlow rules are basically like access lists.
Yes, and so again,
So our work is quite quite extensible and quite applicable here in this working group, even if it's OpenFlow centric.
right, and so these filters and the conflict resolution provide a way to compare policy and way to compare pieces. One of the things we had in our early discussions about priority and priority resolution was how could it really deal with the filter-based RIB, where you're actually putting in essentially an extensive ACL or a packet-based ECA policy. So I asked Pedro if he'd go ahead and give this presentation, because we talked about initially what happened. Right now, we're treating all of the ephemeral work as a single pane of glass, but in the future, we may want to reconsider how clients work, and that had to do with how you do resolution within the pane, the set of panes of glass that are ephemeral.
And
Okay, thank you again.
just one extra, last comment. There was this workshop on last Saturday, and we presented an extended paper on this on that workshop.
Send a pointer to that to list, just so that people know where they can go. And next, Jan, are you presenting? Just a minute, let me get. I've only got a PDF. Just a minute. It's Yanzu one. Okay, thank you. Please go ahead.
Thank you. Thank you for giving me the opportunity to present our draft. This is about data center fabric topology. So the scenario is what we want to talk about here is data center networks. Actually, nowadays with the increase of big data and many applications, the data in the network is much more important. So the data center network is also a big market for not only the enterprise, but also the operators. So next. So with this entire big networks, what we want to do here is we go back to what we are doing nowadays. Nowadays, administrators have to manage the data center networks, each nodes in these networks, not only the physical layer, but also the overlay layers. So when the new overlay technologies or new technologies applying to this kind of big network, and also for the scale of this network size, we have to, the administrators have to do much work. They have to care about each nodes and its applied technologies, which causes the complexity of network management. As we may know, data center is composed of fabrics, which also known as pods. When the data center scales, the operators or the enterprise has to add new ports into this kind of network. So each port will have the similar overlay technologies and the similar structures. So the only thing they have to care about is what is for these ports, and also these ports, how this port can be connection to other ports in the network. So with this concept, we define a fabric topology for on top of the existing physical infrastructures to let the administrators to care about the network in fabrics and the connection between these fabrics. So the detailed challenge or the requirements of this topology stuff can be found on the another draft, which is in SDN-RG. It's from operator requirements. Next. So what we want to do here is we want to ease the data center network management while providing capacity, scalability, and technology extensibility, which means when the data center scales, they only have to add the new fabrics into this whole network and only cares about what this specific fabric use the technology, also the fabrics connected to existing fabrics. So the second one is to build, the second ability is to build a abstract fabric topology for the data center overlay, which maps to physical topologies. So this is a common fabric topology with the common attributes for data center networks, what will we have in ports. So the last one is finally to ease the network configurations to users. Next, please. Thank you. So this is how we use this topology model. So we can use it by controller to configure the spine and leaves the physical nodes in the networks to let the physical nodes to know what kind of role it plays in the whole network. And also it can be used by network manager system to tell the controller how this whole network looks like. So next. Thank you. So this is the relation to existing models in I2RS. As you may see, fabric topology is a kind of new things based on the network topology model. Next. So also potential models is, since we have the different data center fabric types, maybe we have trio fabric and the VXLAN fabric or future GPE fabric topology in the next following steps. Next. So this is how fabric-based data center topology management look like. So what it does is the fabric topology models collect a set of physical nodes into the fabric, and the fabric will care about its connection to other fabrics, and it manages its internal fabric connection and also care about the connection to other fabrics. So it will leaving the administrators with the details of the physical layer stuff. So next, yeah, this is the very simple and initial data models for the fabric topology, which has also has a nodes and links, and it's mapping to the underlay topology nodes. So that's all. I think that's the last slide. Thank you.
So I'd like to give a bit of context and let you ask questions of Ian. One thing that we have stopped our models is we stopped it to the basic L2, L3 topology. And you noticed we sort of stopped our service topology work because we had lots of questions from Michael. Some of the presentation that we're going on here is to look at where that expansion should be for topologies, either in service model or forward. So this is not directly in our charter, but could be as we're sort of getting to the end of the basic charter model, rib, filter rib, and topology. We're going to allow some of these other discussions, conflict resolution, data center fabric, as reasonable extensions to our model. They are not, I'll repeat, in charter, but part of our discussion. So given that, is there any feedback for Jan on her model or on your thoughts on its usability?
Just as feedback, this is Alex Clem. So I think as an application, I think this absolutely makes sense. And yeah, and we'll also, I know we have some discussion this afternoon.
Yeah, yeah, we will have a detailed discussion on the whole models and see.
Good. I'm glad it's helpful. We're thinking about applications and other things. Well, we've ended up early unless there are other questions. Any other questions for Jan?
Yeah, just have the general question. So what are the next steps then regarding also those models and moving them
So,
through the process?
That's a process question on the topology model, so you can have a comfortable seat. Thank you so much, Jan.
Thank you.
So the process, good question. What is the process model on the topologies? You had a few things for the layer 3 topology, which has been implemented, and the base topology, which has been implemented. You need to correct those drafts and then send a note to your working group chair saying, I'm ready for my working group last call. Chairs, excuse me.
So I think the base model, I think we are basically ready with it. I think the one that needs some update is the layer 3 model, and where we have some of the items where we know there's some work to do, but I think with regards to the basic model, yeah.
Do you want to send them through together or separately as the author?
I
or
think
one of the authors?
Okay. Well, I mean, some of the other authors are here. My opinion would be, I think we don't have to package them. We could do that separately because I feel also the general topology is the foundation or basically the base model for some of the other things in there, whereas the L3 is kind of like in parallel with the other. So I feel it's probably important to get the base thing through. We should not have the layer 3 progress holds the base model up.
Okay, so we will start the base topology model, Yifa?
Yes. Question about so it's currently there's a discussion about the upper state in that mode. So that may affect our models here. So do we want to wait on them or we don't need to?
I had a long and vigorous discussion with this at the routing chairs meeting. And I think the answer I got from Benoit that he guaranteed me that we're just going to go ahead. And if this means we refactor models later, my understanding from the discussion yesterday, and you can correct me, Aaliyah, is we're just going to go forward.
Right. Oh, yeah. No, I'm not trying to correct you on that. Though one interesting suggestion that Lou made in R2GWG that the routing Yang architecture design team is considering is suggesting that for models that have the applied and intended, that you could use the intended as basically you could treat the extra tree as an augmentation so that you could sort of have your cake and eat it too. They're still talking about that, but it might be interesting. What I was actually going to request is, as we develop knowledge of implementations, particularly for the models, it would be really nice to put that up on the wiki. One of the tricks here is making sure all the models are going to interoperate and connect up properly. And so getting some sense of the implementation state and how they're, what's been played with together will be really helpful for assessing it. I'm very eager to have the Yang models in this working group move forward. Thank you.
Okay, and Alex, I think we'll create a wiki spot, and I'll send you a note on what to give us as input from your ODL topology. Go ahead,
Yeah,
Yifan.
one more thing. Actually, the apply versus the intended configuration does not affect us.
Yes.
But in general, other upper state discussion will, I think, will be discussed this afternoon. That may affect us. So
Yeah. So I had a lively discussion with Benoit, and his answer to me when I said, "Do you want me to just wait until you decide what you're going to do?" was not to wait, and he would help us if we had to refactor things in a subsequent version. So we're not going to wait. We're just going to approve and go on. Joe?
Joe Clark, may I make a context switch?
Yes.
So Andy commented on the list, Andy Bierman commented on the list regarding the new text for 07, bringing up, he didn't say it, but bringing up the multi-head text in 11, requirement 11, where we do not necessarily, in fact, it's a lot of mays there. The data node may store the client ID, does not need to store the priority. His comment is, well, if the priority can change for a client, be it AAA, and we only store the client ID, then the priority could cause us to reevaluate what the final state is. That client A's ephemeral config may dynamically overwrite client B's. He's suggesting we also require of the netconf working group that we store priority in addition to client ID. I haven't fully digested it. I'm just bringing it up here to say that we probably may want to revisit requirement 11, the text in that.
Having actually taken time to write the code for that, I don't really think it matters because it really is a pointer to a particular set of client IDs and priority, where if you're storing it, if you're storing a set of essentially a transaction session ID that is created out of, you're just pointing one to the other. I don't see having actually taken the time early on to write that code, knowing we sort of need to know. I don't see where he's coming from, but I'm glad to engage him on the list if he has it. Because it's just a pointer, right? It's a pointer to one or the other. Do you have a comment, Aaliyah?
Yeah. Sorry. Aaliyah Atlas, just as an individual. So we've been around this circle before, and a piece of the discussion was, if the priority changes for a client, do we go back and apply that priority to everything the client has previously said? And my understanding of the end of the discussion was no, it's a change and you take it for new pieces coming forward, but you're not going back and reapplying. We also put in the simplification, as you recall in Prague, about a year ago. The reason we had a discussion about maybe you can you just store client ID instead of client ID and priority was to simplify and to let the overlaying panes of glass approach work more easily. I obviously discussion about it might have changed, but we're so close to just finishing this stuff. It would be really nice not to reopen discussions we've had unless there's a really strong change in consensus.
Having looked at the code and doing this, what you really, I don't want to reopen 11 unless the working group strongly encourages me to do that. Okay, I agree with the AD.
No, that was just me, Aaliyah.
Okay, Aaliyah.
No AD head.
The other thing is, in reality, what you're talking about is if you say that you're going to go back and reevaluate it, the most efficient way, if you do route tables, is to consider the priority change a route change that goes across all the pieces, which you would probably set up a change list and walk through it anyway. It's really just the standard, changing the requirement doesn't change what you're going to do. And it really makes it a little less clear how a route table works. But that's Sue talking as implementer, not chair.
Right, but that's for, if you think about the I2RS agent handling the priority, then figure out what to communicate down to, whether it's to the RIB manager or other things, what you described requires significant. That's not a general solution. That's just for the RIB manager for implementation. So
that's correct. That's just one example. Okay. We'll probably have to confirm. We'll start with what we have and then go on with the final working group call. But I will look again, Joe. Any questions you can think that? I mean, I tried to give you my personal answer, but not the working group chair answer on that. Okay. Any other things that we should think about specifically on the requirements or the topology working group last call? Thank you for coming in and putting the extra time into this. We really appreciate to help the topology drafts go further and to help us do a better job with the implementations.
We didn't do straw man.
Pardon?
We didn't do straw man.
No, I didn't do straw man. Talk about straw man this time.
That's fine. We just don't need this, and I just want to make sure we don't intend to.
No, the way I talked about it was earlier when I did the diagrams. Okay, so you're fine.
Hey, Joe. I think I tend to want to process this because these changes to say, I want to increase my priority. Not necessarily